QSO Today, episode 445, Nick Tusa K5EF. This episode of QSO Today is listener-sponsored and commercial-free. Only you can keep the QSO Today podcast coming to you every weekend since 2014. Please become a listener sponsor monthly or annually by clicking on the sponsor banner on the show notes page or at the top of the QSOtoday.com webpage. Beginning with episode 445, I'm recording the podcast in video format for old and new listener sponsors to view uncut from end to end without commercial breaks. If you'd like to watch the QSO Today podcast, even with closed captions for the hearing impaired, become a listener sponsor by clicking on the listener sponsor banners in this week's show notes page. Welcome to the QSO Today podcast. I'm Eric Guth, amateur call sign 4Z1UG, where I demonstrate the diversity and relevance of the amateur radio hobby and its impact on society by interviewing ham radio operators, many of whom played vital roles in shaping our technology through the amateur radio hobby. And while many people might say, ham radio, do people still do that? This podcast demonstrates through in-depth interviews just how amazing, diverse, and dynamic the amateur radio hobby continues to be. Nick Tusa K5EF embarked on his ham radio journey as a teenager in a New Orleans Jesuit high school, where he was introduced to cutting-edge technology of a Central Electronics 10A single-sideband exciter at the school's ham radio station. This early fascination sparked a lifelong friendship between Nick and Wes Schum, W9DYB, the co-founder and chief engineer of Central Electronics. Over the course of their 50-year friendship, Nick not only built a successful career in radio and communications, but also became Schum's biographer. K5EF is my QSO Today. K5EF, this is Eric, 4Z1UG. Are you there, Nick?
Eric, I'm copying you 5 and 9 in Covington, Louisiana. How are you?
I'm great, Nick. Thanks so much for joining me on the QSO Today podcast. Can we start at the beginning of your ham radio story? When and how did it start for you?
Well, actually, for us guys that grew up, born in the 50s and grew up in the 60s, my story is probably very similar to a lot of others. I got interested in electronics or electricity at a very young age. I was just curious about, how do the lights work in our house? And this is when I was a little kid. And then I wanted to know, how did the electricity that lights the light actually get to the house? So I kept asking questions. My teachers, my parents, they got me books about electricity. This was when I was really young, and mostly they were picture books. But when we go out, I'm looking at power lines and substations. And finally, my dad actually brought me to a power plant that was in New Orleans, which, for a kid, hear all this stuff whirring in the background, it just kind of got you interested more in how electricity works. And but then I progressed. I started tearing apart motors and alternators and starter motors, because my parents, it was a family business that was in the automotive business. They did parts, and they had junkyards and all kinds of things. So my dad would bring me the stuff to tear apart. And so I got more and more interested in how these things work. And if, in fact, once I tore one apart, whatever it was, if I could put it back together. So one day, when I was 8 years old, I spied my grandmother's AM radio on the kitchen counter. She was doing something else, and I'm looking at it, and it's got this music, this New Orleans jazz music playing. And I wanted to know where the sound was coming from. So I looked in the back, and I could see these little small glows of orange light. And I thought, I bet the sound must be coming from somewhere in there. So thank God this thing had a transformer in it, because I didn't electrocute myself. But I was able to get the back off, and I saw these glowing embers, and I touched one. It was hot, but I pulled it out. And I said, well, gee, I wonder if it's in there. So I looked at it, and I couldn't see where the piano music was coming, and they had some more tubes in it, so I pulled the rest of them out. Never did find where the sound came from. But then I had a pile of radio tubes, and a radio didn't work anymore, and I knew I was going to get in trouble, right? So my dad got home. He said, well, fella across the street has a garage TV repair shop that he operates in the back of his house. Back then in the late 50s, just about everybody had a neighborhood guy that was interested in TVs and repairing them. So we brought the stuff over to the neighbor, and he got a good laugh out of it. He plugged everything back in, got the radio working. Of course, I figured I was going to be in the doghouse, but I wasn't. You know, the fellow across the street, our neighbor, Mr. Evans, kind of saw that I was interested in this stuff. And he said, well, look, come on over here. I'll teach you more about radio, you know. And pretty soon, I'm just an 8-year-old kid, you know. So he's got the Sylvania tube manual out. He's showing me how to read the base diagrams of tubes. Pretty soon, I'm testing tube filaments with an ohm meter. And he starts giving me more and more little assignments to do, and he hooked me. So eventually, my dad took notice of this because I was always at Mr. Evans' house and not at home. So he said, you know, maybe you would be interested in this ham radio class that they're giving at a playground. So he brought me and one of my cousins to this class, and they were teaching Morse code. Well, I never heard Morse code before, but it was just kind of neat and interesting, you know, and it sounded like music to me. So pretty soon I'm enrolled in the class, and we're trying to learn this stuff. But I'm a kid. I'm not really, you know, from an education standpoint, I didn't have the background to understand a lot of the theory part. But I picked up pretty quickly on the code. So eventually, by the time I got, I guess, to 11 years old, I was able to pass my novice exam. And soon after, when I was 13, I passed a general class. And back then, in those days, you had to go for the general class exam, you had to go before a FCC examiner. You had to go to the FCC office. So you don't have to do this, of course, today. You have volunteer examiners that do this stuff in either a ham class, a ham club, or at a ham fest. But back then, you had to go to the FCC. And, you know, when you're a kid and you get in that elevator and you go up 6 floors and you go in this office and you see all these people typing, you know, because they had, you know, stenographers there. And you see all these older folks in there with headphones on because they're getting ready to hear the code test. Back then you had a code test first and a theory test next. And for the different classes. So like general class was 13 words a minute. You had to copy it and also send it. And if you were standing in for an extra class license, it was 20 words a minute. And if you wanted a commercial radio telegraph, it was 25. So I'm in there. I'm just this little kid. I'm all just knocking on 13, you know, and scared to death. And it was just it was an exhilarating period to come take that elevator ride back down and know I had actually gotten a license. That was how I got interested in ham radio.
What year was that?
That would have been 1965. And, well, actually, late part 65, early 1966.
And what was your first call sign?
My first one as a novice was WN5NID. And then when I became a general class ham, my call was WA5RMC. Here's an interesting story about how you found out what your call sign was going to be. Okay. You know, you generally had to wait until the FCC sent you the letter that had your actual license in it, in the mail. So, you know, us kids, we'd be expectantly waiting at the mailbox every day for this thing to arrive. But the first thing that you got, probably 2 weeks before your license, was a little package of sample QSL cards from the little print shop that was in, I think it was either in Texas or in Oklahoma. And on the label, they had your call sign.
So isn't that interesting, Nick? Because I bring that up probably 6 or 7 times in 445 episodes. The majority of time, people don't remember it or they haven't heard it. And so I'm glad that you've now kind of vindicated me that, in fact, that was what happens. Because in 1973, when I got my first license, I also got a package of QSL cards from the Little Print Shop, and that's how I found out my first call sign.
I was so sad to see when the Little Print Shop went out of business because they did such a wonderful thing for Hamden. Not just QSLs, but letting you know what your license was or your call sign. It was great.
Do we know how they got that information? I mean, this is pre-computers.
Yeah, that's the amazing thing. All of this is pre-computer, pre-internet. It was fascinating. I honestly don't know how they got the information, but they did. They had the inside track because the only one you got a package of QSL cards was from the Little Print Shop.
And mail seemed to move pretty fast in those days. In fact, I remember, at least in the early 60s, you had 2 mail deliveries a day.
Yes.
Morning and afternoon, so you could actually send a note across town and have a reply. Oh, that's very interesting. Okay, so what happened after that? You have a general class license, you're 13 years of age, and did you say that the hometown was New Orleans?
Yes, I grew up in New Orleans, yes. Yeah. Covington, where I live now, is across Lake Pontchartrain. It's on the North Shore. So quite a good distance away from the hurricane surges.
Right, but you're still in the area.
Oh, absolutely, yes.
As a 13-year-old with a new general class license, what did you do? Did your high school have a club or have a station?
Yeah. Well, the interesting thing back in that time, because, there was no internet, and all of us young kids got really hooked on shortwave radio listening. This is even while I was studying to be a ham. So, my dad had got me a shortwave receiver, and I would just spend hours a night listening to these broadcasts from all over the world. And, this is at the time, you're talking about the early 1960s. The Cold War was going on, lots of angst between the United States and Russia. And, and you would hear all these strange signals on the shortwave bands. You would hear what sounded like, to us kids, it sounded like B-17 bombers flying. Well, really, what that noise was multiplex teletype stuff, And then you had number stations where they would folks would be sending Morse code letter and number groups, because all this stuff was coded, encrypted. So there was lots of things to listen to, and your imagination as a kid just runs wild, right? You felt like, and the James Bond movies were just coming out back in the early 60s, so you felt like you were a spy. You were listening to all this stuff, and none of your friends knew anything about it, because they weren't interested in shortwave radio, but you go to school and say, man, guess what I heard last night? All of a sudden you became the center of attention. What
was the first receiver that your father got you?
Well, the first one I had was a Hallicrafters, S119. It was a general coverage receiver that did absolutely nothing good. But you could pick up these broadcast stations with it. My antenna was the mesh screen on our window, But when I became a novice, my first rig was a Drake 2A receiver. He had got me an ICO 720 kit that I put together, and somehow it actually worked. But again, I'm pretty sure I brought it across the street to Mr. Evans so he could bail me out if I made a mistake.
Now, was Mr. Evans a ham?
No. What he was a master machinist. And he got interested in electronics as a hobby, because it was so much different than what he did during the day. And so he opened his little bitty radio repair and TV shop up in the upper floors of his garage. So whenever I'd see that light on in that upstairs window, I knew the coast was clear for me to zoom over there and help him out.
What I remember from that time was television repairmen that made house calls carry these huge tube caddies.
Oh, sure, yeah.
So they had every tube.
Well, back then, you had a repairman for everything, or a delivery man. You had the milkman, you had the fella that brought you clothes, the cleaners. They had the egg man that brought fresh eggs to your house. The postman, of course. The telephone man actually came and fixed your telephone. And, of course, the TV man. So you had a man for everything.
Yeah, those were the days, weren't they?
They certainly were.
And so when you got the general upgrade, did you upgrade the rig too?
Oh, yeah. At this point in my life, I was starting to work at the family's businesses, in the summer and on weekends. So I started earning money for my hobby. And my dad, of course, would kick in some extra cash too. And one day, this was after I got my general class license, I come back home and in my little ham shack, which was built in the utility room behind the house, there's a Swan 350 transceiver. So suddenly I was on single sideband. I mean, I'm sorry, I enjoyed the ICO 720 and crystal control, but all that went in the garbage can because now I had a VFO and I had 300 screaming watts and I was ready to go.
I'm looking at you live right now using your Starlink internet connection to your house.
Right.
It's obvious that you like single sideband.
Yeah, sideband's in my blood. And I'll tell you how that happened a little bit. 20 meters was my band. I love 20 meters. You could put up a reasonably sized dipole antenna. In fact, my dad and a couple of his friends helped me build my first antenna. The sunspot cycle was just starting to come back when I got my general class license. I thought conditions on HF were going to be like that forever. It was fabulous. And eventually 10 meters came alive, so I put up a 10-meter dipole, and I'm working the world with very few watts before I even had a linear amplifier and with dipole antennas. I mean, it was just fascinating to me. But by that time, I was ready for high school, and I went to Jesuit High School, which is a Catholic high school in New Orleans. But all the high schools had ham radio clubs back then. All of them did, the public schools as well as the parochial ones. And, even though I was in this one school, I started developing friends all over New Orleans because we'd all talk to each other on the air at night. We'd sometimes get on 10 meters, when the band was dead. It was like having your private internet chat like the kids do today. Yeah, well, it wasn't very private because anybody in the world could hear you. In fact, sometimes you'd be talking to a fellow across town, then instantly this 40/9 signal from New York would be blasting in. And as he's talking to you, you're watching the S meter take a dive, and he finally goes away. But that was what was just so fascinating about ham radio to a young kid, is that it was just so unpredictable. You didn't know who you're going to talk to next. You didn't know how far your signal was going to propagate next. And the hobby had so many different facets to it, you couldn't ever get bored. There was always something new to try, something new to experiment with, something new to experience. And that was just, it was just magic, But in any event, I made lots of friends through the radio club. And in fact, many of the guys that were in the radio club at Jesuit High School, I'm still friends with today. We get together at Hamfest. Several of them live just down the street from where I am, so we go out to lunch. It's just great. It's like we never grew up, except when we look in the mirror.
Well, that's certainly true. I feel the same way. Let me ask, did ham radio play a part then in the choices that you made for your education and career?
Absolutely. When I was at high school, and this is how I got interested in central electronics and phasing, we actually had a priest that had some equipment there. It was a Central Electronics 10A Exciter, a homebrew pair of 811 tubes as an amplifier, and a 75A1 Collins receiver. And we just about wore it out, But what interested me was I knew how a single sideband radio worked, the filter type rigs. But I opened the top of the 10A, which you had to do in order to change bands. You had to plug different coils in, the mixer coil and the final coil, to move from one band to the other. It wasn't band switch. But I looked inside, and there was no crystal filter. So I'm thinking, well, how does this thing work? How does it generate single sideband energy? Because I hadn't heard of the phasing method at that point in time because it wasn't popular anymore in the early 60s. It had gone out of style with the advent of inexpensive crystal and filters and Collins with the mechanical filter. So I'm looking at this thing and I don't understand how it works. So, and that's the thing that's so neat about ham radio. It forces you to learn new things. You know, it really challenges your imagination and it makes you want to understand why, how and why, which is what engineers do. They think in terms of, you know, why does this work? How does this work? How can I make it better? What can I do to improve this? That's what engineers go through in their thought process. Well, you know, I'm trying to figure out how this works. I'm studying everything I can about single sideband, and there were lots of books. ARRL had books on sideband, and but more importantly, I wanted to put the 10A on different bands. We only had two sets of coils, 80 and 40 meters. So I wrote to Zenith because I learned through QST that Zenith had Central Electronics, and then it went away. So I wrote a letter to them to find out, well, how do I make these coils? I'm just a kid, right? I'm writing this big corporation, don't know anybody over there, so I just send a letter to them, right? I get a letter back from this fellow by the name of Carl Hassel. Didn't mean anything to me at first. He sends me the coil data. He tells me about this fellow Wes Schum that was the president of and Central Electronics that had designed the 10A, and he gives me his address and a phone number. Well, it turns out that Carl Hassel was the co-founder of Zenith Radio. So here it is, the co-founder of Zenith sending this information to some kid in New Orleans, Louisiana, to try to help him out and to further his ham radio career. I thought that was just, you know, when I think about it now, it's just fantastic. So I started this conversation with Wes by letter first, because I didn't have that's enough to call him up. So I sent him a letter, and he would respond back. And we did this all throughout my high school years as I was trying to learn more about the phasing method. He would actually teach me about it by little notes and letters he would send me. And by the time I graduated from high school, I knew exactly what I wanted to do. I wanted to be an electrical engineer, and I wanted to design radio equipment. So that's what I did. I enrolled at Tulane University, got my degree in electrical engineering in 1975, and shortly thereafter, I embarked on my professional career, which was initially it was radio communications in the petrochemical industry, because the oil industry was all over the Gulf of Mexico and adjacent coastal waters. So I went to work at Exxon, and I was an associate engineer there, and eventually worked up the ladder to be a senior staff engineer in communications, and then branched out and started my own companies. But ham radio played such a pivotal role in charting my career. And, you know, as a professional in radio communications, it's hard to find where the line is between being a professional in it and still having it as a hobby. To me, every day is like I'm going to work in my hobby because it's so much fun. It's still fun today. I'm going to be 70 years old at the end of April, but I feel exactly the same when I get on the air downstairs on 10 meters. I got a rig warming up, waiting for the band to open up, but I'm just as excited when I get on the air on 10 and work DX as I did back when I was a young kid. It's incredible.
That's a very interesting point that you're making, because I remember as a young father, I'm working in radio and electronics all day long, and I came home and didn't do it. How did you make that separation between work and home, and what was the difference between the two?
Well, we did two different things professionally. I designed public safety communication systems for police, fire, and EMS. So I did it for cities and counties, and did some studies, at least for a couple of states, but principally my work was for cities and counties. And we designed the radio systems, get vendors to come in, bid on them, and manage the implementation of them.
So in those days, this would be like VHF, UHF, mobile systems, right? Dispatchers.
Yeah, initially it was VHF, UHF, conventional systems, very similar to what ham radio operators use today on 6 and 2 on 2 meters and UHF 440. Single site repeater stations, that kind of thing. But as the need for more channel capacity and more utilization of the radio for the missions, the systems got more complicated. So they started adding more frequencies, more transmitter sites. Then the advent of the portable radios meant you had to have remote receiver sites and receiver voting. So these systems became more and more complicated. And then when trunking came in, where you use a pool of frequencies and the systems dynamically assign channels for you to operate on by every push to talk that you make with your radio, then it went from an F-150 pickup truck to suddenly you're building Ferrari radio systems. And they're so different than what I do in the ham radio world that there's enough separation that one's work and one's a hobby. And what really makes it different is the public safety world was all state-of-the-art digital radio systems, Project 25, AMBE, digital vocoders, all that stuff that is cutting edge is being used by hams today with their DMR radio networks. And so what I do to make it fun again, I rebuild vintage radio gear that uses vacuum tubes. I went the other way.
You and I are talking on Skype, and we're doing a video conference as we're doing this interview. And, of course, I see probably one of the oldest Collins general coverage receivers behind your shoulder there, right?
That's a 75A4. Yeah, that's a Collins ham receiver. Yep. But on the other side, I've got some other Collins general coverage rigs, yes.
And then there's, of course, the Collins S line built into sloping fronts and a linear amplifier on your side there. Is that right?
Yeah, right.
You have a little bit of everything. All of the rotor controls, you at least have 3 rotors, which must mean you have 3 towers in the air somewhere.
Well, actually, there's 4 of them. Okay.
4. Maybe your head's blocking the 4th rotor control. I mean, it's a fabulous-looking station, and looking on the video, it's really great. Let's talk a little bit about restoring vintage radios. Or actually, maybe we should back up, and you mentioned Wes Schum. And, of course, you wrote a book about Wes Schum.
Yes.
Can we talk a little bit about what was Wes's, first of all, his call sign, what was his relationship to amateur radio? Was his story similar to yours, where he started as a youngster interested in radio and it led him to Central Electronics? Could you talk a little bit about that?
Wes Schum, his call sign was W9DYV, Delta Yankee Victor. And he grew up in Chicago. He was interested in radio at a very, very young age. He had a very interesting life. His father made cigars. Then when Prohibition hit, he was a bootlegger. And Wes went on several of his little excursions at night, which was in the book. You know, it's kind of interesting. But he got interested in radio very early. I mean, like radio back then in the 30s, early 30s, was very much like the beginnings of the internet was in the late 80s, early 90s. You know, and it captured the imagination of young people. Well, radio definitely did. When World War II came about, there was such a tremendous need for people that were radio fluent, both designers and operators, that the ham radio league group provided so many resources to the federal government to get us moving in terms of communications, because we were really in a bad shape communication-wise. I mean, they had to have classes all over the United States and teaching people how to listen and understand Morse code. But in any event, he got interested in it very early. One of his stories was when he was a young kid, he used to go down to the E.H. Scott factory, which was on Ravenswood Street down in Chicago. Yeah, they had these windows that were, I guess, maybe about chest high on a kid at that age. And then he was probably about maybe 13, 14 years old. And he would look down and he would see them building these fabulous E.H. Scott radios, which would be, they were the Rolls-Royce radios of the time. They were custom built to order. You didn't go to a store and just buy one. You had to order it. They built it just for you, you know. So he's looking through the windows, and the foreman down in the assembly area noticed him there just about every day. But finally invited him in, and they really took him under their wing and showed him all the different processes involved in making electronic or radio equipment at that time. And that just hooked him, you know, and he began fixing radios for Good Housekeeping, had a series of technicians in Chicago, and he became the 13th one. And he had this uncanny ability to fix all the dog radios. The ones that nobody else could fix, they would give to Wes Schum, and Wes would get them working. He was deferred during World War II because of his engineering capabilities. He had gone to work for a company called COVID Dual Signal Corporation. And it was they built equipment that, well, kind of like what I do today in the public safety realm. They built call boxes that were installed throughout the city. And if you need a police and fireman, you would open the door, pick up this handset, and it would ring at a dispatch center, and they would dispatch a policeman or fireman or wherever it was. So he went to work for them during the war, and suddenly they were building all sorts of products for the military. And Wes was very much instrumental in building equipment that was quite unique. One of them, the most important one, contribution to the war effort that he was directly involved with was a system of paravane technology that was used to destroy German U-boat torpedoes. Paravanes were towed behind minesweepers, and they had explosive charges at the end of these tow lines. And what they did was they developed these hydrophone or underwater microphones. And Wes's project was to develop and build for COVID Dual a tuned ultrasonic audio amplifier that was tuned to the frequency of the propellers of the torpedoes as they went through the water, which happened to be 54 kilohertz, as it turned out. Well, they designed these amplifiers that had a thyrotron gating arrangement. So once the torpedo got close enough and the sound level built up high enough, it would trigger a thyrotron, which is like a silicon-controlled rectifier today, and would blow up the explosive charge at the end of the nearest paravane to where the sound was being picked up. And it would pancake the torpedo. It became so successful that the Navy actually brought photographs of pancake torpedoes to COVID Dual Signal so that the engineering team could see how important their contribution was. It dramatically reduced the number of sunk ships, these convoys that were going back and forth between the United States and England, because England was on the ropes. They needed the United States badly to supply it with food and material and all sorts of things during the war effort. And the German U-boats were sinking them like crazy initially in the war, but that changed once the United States developed first better torpedoes so that they could actually sink some of these German submarines when they needed to. And because of these more sophisticated paravanes that actually protected the supply ships in transit from the United States to England.
Well, that's fascinating. I don't think I've ever heard of paravanes before.
Yeah, well, neither did I, but I learned quite a bit from Wes.
What's interesting is, the United States actually didn't enter the war until 1944. It took years to actually build the airplanes and the boats and everything else that they needed to land on Normandy, for example.
Oh, yeah. Well, that was built in New Orleans, by the way. The Higgins company built the landing craft that we used throughout the Pacific War, and also the landing the personnel on the beaches in Normandy. Those were all Higgins craft, developed by a guy in South Louisiana that the only thing he knew was fishing boats. But he developed that, and it worked like a champ.
Okay, well, I'm putting all of that in the show notes here. And now this mid-show break. You can keep the QSO Today podcast commercial sponsor-free by becoming a listener sponsor yourself. For $10 a month, or save 20% at $100 per year, you can become a listener sponsor. I'm now recording the QSO Today podcast as video interviews that are available only as a benefit to listener sponsors through our QSOTodayCommunity.com website. As I develop the sponsorship tier, I will add bonus content for listener sponsors. The benefit of listener sponsorship as an alternative to commercial sponsorship is that commercial sponsors influence the content and comments in the podcast. Commercial-free allows a greater degree of freedom to discuss any ham radio subject without commercial consequence. I have eliminated all commercials in the QSO Today podcast from episode 445 on, with the exception of the Ham Radio Workbench podcast, as I think it is a serious asset to a well-rounded ham radio education. I'm not using Buy Me a Coffee or Patreon anymore, but my own system for managing the community that could form out of the podcast. I direct you to the sponsorship section of the show notes pages beginning with episode 444, where I list all of the contributors to the podcast since 2014, including sponsors, donors, and hams who have paid for the transcriptions. There is a new section where I list the most recent sponsors and donors over the last 30 days. This list is generated automatically from my membership system. The new sponsors in the last 30 days are Dominic Tusa K5EF, $100 annual sponsorship, Mark Seidel KR3AM, $100 annual sponsorship. New donations in the last 30 days are John Simmons NI0K, $10, John Barrett KC180T, $50, and Philip DeHulster ON7FD, $50. Our funding model is now value for value, where you trade with me your time, talent, or treasure that you think values the benefit of the QSO Today podcast to you. If sponsorship is not your interest, then you can make any size donation to the podcast by clicking on the donation button on the QSO Today podcast website at qsotoday.com. There is a slider that you can use to adjust the amount of your donation. If you want to make your donation monthly, click on the recurring donation box. It is the recurring donations that keep the lights burning here. I want to thank everyone who has contributed and will contribute to my effort to create this oral history of amateur radio since 2014. It will eventually all be in the public domain for hams in the future to enjoy. Be sure to become a listener sponsor or make a donation today. And now back to our QSO Today. You developed this relationship with Wes over this period of time from these notes that you were sending back and forth to him as a teenager. How did that relationship mature?
Well, when I was in college, first off, I was fascinated by the fact that Central Electronics suddenly disappeared. I mean, they were on top of the world in the 50s. They were the premier developer and marketer of single sideband equipment. And Wes Schum was the engine that did it. He went to Hamfest all over the United States demonstrating single sideband and how it was superior to amplitude modulation. Superior in the sense that it reduced the occupied bandwidth of the channel by half, because an AM signal, if you modulate it up to 3 kilohertz, it takes 6 kilohertz of spectrum. But you only need the information in the upper and lower sideband in the AM a signal is redundant. It's the same information, both the upper and lower. So the thought was, and this all developed rapidly during World War II. Lots of people don't know that single sideband was used in World War II, but it was primarily by AT&T for multi-channel telegraph communications between the United States and England and some other locations. But in any event, the technology was being improved for radio during the war. And lots of people, well, not say not lots, but numerous people that were involved in that build out saw the need for single sideband in the amateur radio circles, because the problem with AM, and if it's concentrated in a small amount of spectrum, if the signals are close together, you're going to have beat notes or heterodynes, and it makes it very difficult to communicate. So only the strong, I mean, the guys that were running these big, as they used to call them, California kilowatts and big Yagi antennas, could blast through the pileups and squish all the little bitty lower power stations and smash them like a grape. That's the only way you could communicate. And it was just a mess. And Wes would hear that constantly as a ham, and he's thinking, man, when I get out of service, I got to do something to try to eliminate these heterodynes. And he read a lot about the work that was going on in the military with single sideband, because he was involved in he got drafted after the war, actually. The war ended, and his deferment at Cobra Dual Signal, which was a company that was building this wartime equipment, expired. And so right away they draft him and bring him into service. In any event, that gave him a gateway to some of this new technology that was being experimented with in the military. So he thought, well, this would really have a great application in ham radio. There were some other hams that were interested in doing it too. There were some amateurs at the Stanford University in California that were experimenting with single sideband, and the General Electric Company in New York, Rochester, New York, Syracuse, New York, was experimenting with single sideband also. In fact, they did in fact build the first single sideband systems that were used by the military. It wasn't Collins Radio, it was GE. So he thought, well, there's got to be a way of making this stuff affordable for amateurs to experiment and use. And about that time, a fellow with General Electric had developed and published in GE Ham News a very, very simple single frequency, single sideband exciter. It's called the Single Sideband Junior. Wes saw that and said, man, this is what I need to do. I can take this basic idea, expand it to make it multi-band, kit it, and sell it to the amateurs to get them experimenting with single sideband. And that's what he did. That's how he started. His business started in his basement on his house on Giddings Street. He eventually he grew to the point where he had to take over the garage. Then he took over his neighbor's garage. Then he took over 5 neighbors' garages because they had a service alley behind his house. And he was hiring kids out of the Rye Technical Institute to help package and build these things up as kits or as assembled units. And he bootstrapped the company out of nothing, really. And he continued to innovate. And by 1955, he and his business partner, Joe Batchelor, had invented and built the first broadband no-tune linear amplifiers called the 600L. All you did was change the band switch, and it automatically was set to go on each band. No plate dip and load and all that stuff. It was all done automatically. And then they developed a transmitter to go with it. It was called the 100B, and then a 200B, which is a more advanced version of it. Zenith had bought into the company and was actually building those products, and then abruptly shut the business down in 1962. The reason for that was color television took off in the United States. There was enough broadcasting in 1961 that Zenith had developed color TVs, the technology for it, but was reluctant to market them because they didn't feel there was enough programming to justify the cost of the receivers. But then by the end of 1961, there was enough broadcasting that they felt it was safe to do it. They had started selling their TVs to the tune of, and this is in 1961, $270 million worth of color TV. Now you figure what that would be in today's money. Now, back then, Central Electronics was doing about $3 million a year. So the management got together and said, we got 270 million of volume here, and we've got this little company that's doing 3 million. Why do we need that? So they deactivated the ham radio line, but they still used Central Electronics, which is what most people don't know. It continued on for several years, building stereo equipment and FM equipment for Zenith Radio because it was a non-union shop.
So what happened to Wes? This is 60 years ago.
Yep.
What happened? I mean, we're still talking about Wes. We're still talking about Central Electronics. With all due respect to Wes, it sounds like it was a flash in the pan. As a company history, it wasn't a long history.
No, it wasn't. No, it wasn't a long history, but it took off like a rocket ship. It got a tremendous following. I mean, he really pushed a lot of folks into single sideband. There's little 10A exciters with Cream and Art Collins on 20 meters. You know, Art was running a big KW1, but, you know, I had these guys in Chicago that was running these little 10-watt exciters driving a pair of 811s, and it was just running circles around this KW1. I mean, they were killing him. Collins actually bought some 10As from Wes, and they eventually showed up in their single sideband development lab. So the reason I think that Collins abruptly got out of the AM business was because they could see the vast market that single sideband had, certainly in the amateur business, but more importantly, they had the vision and connections to see where its application would be in the military. And that was their primary focus with Collins, was to move into the military market. But knowing that amateurs were pretty well ingrained in military operations, and that would be one way of bootstrapping their business in that respect.
Isn't it fascinating to you, though? Because I think we can make this connection now, that we see the migration of flex radio into the military market. What's so interesting is the military uses amateur radio as this proving ground.
Proving ground, yep.
Before it commercializes and takes it over.
And Zenith wanted to do that. You know, they saw the value of this technology that Wes and Joe Batchelor, his engineer, developed at Central, and they saw the value it had in the military market. They could see that. You know, Zenith was heavy in the military during World War II, building frequency meters and also proximity fuses. You know, most people don't know they did that, but they did. They were heavy in the proximity fuse business. The only problem with a proximity fuse is it isn't around very long. You know,
you need a lot of them.
Right. Yeah, you need a lot of them. You need a lot of reason to have them, right? So they didn't have the same type of military connections like Collins Radio did, you know. So they weren't able to penetrate the communications market. And I think that was the big problem. The other one, of course, being that they saw that television was taking off like crazy. And they just didn't feel like it was, yeah, it might have worked for them, but they didn't want to invest any more money into it. But they also didn't want to sell the company back to Wes because they felt like, well, we've got all these patents on this technology that nobody else has. So maybe in the future we will use it. So suddenly, Wes found himself without a company. He found himself without an ability to use any of the things that they had invented. And so he had to reinvent himself. And I think that is an important lesson for anyone young person that's getting involved in the electronics industry, is that there are going to be obstacles in your life and things that you're not going to be able to control. It's not just electronics, it's any industry, really. You know, but you have to be adaptable. You have to find another way. And he did. He found another way. He built, once Central was deactivated, he was building language lab equipment for the J.L. Warren Company in Chicago so that young children that couldn't hear could suddenly be able to hear sounds and were able then, able to to learn how to speak. So he got involved in the language lab business and was in it for close to 35 years. And in addition to that, some of his ham radio connections got him stitched up with Western Electric. Western Electric was having problems in, well, first AT&T, Western Electric, both. They were being forced by the federal government to allow interconnection into the Bell telephone network. But there were conditions on that where you had to have isolation, electrical isolation between external equipment and Bell equipment. So they needed test sets in order to determine whether or not somebody's external equipment met the spec. Well, guess who built it? Wes Schum.
Oh, that was the Carter Phone Act, right, in the early 70s?
Yep. He got involved in building test sets, first for AT&T and Western Electric, but then he started having inquiries about problems at ADC, which was a company that built telephone jack fields. If you've seen these long rows of jacks in an equipment rack made by ADC, well, they were having problems with a high failure rate on these jack fields, and they're very labor intensive to make back then because you had the connectors in the back, but you had the jacks in the front, and they all had to be wired individually to the jacks. So there's a lot of wiring that goes on. So you spend a lot of time building this jack field up, and suddenly maybe it's not paying. Some of the jacks are defective, and they don't understand why. Well, they wanted a test set in order to test these jack fields. Well, Wes got the assignment through his ham radio connections again, and he started working on the test set, but then he found out what the real problem was. There's a lot of machining that goes on into making up these jacks, and there's a lot of tapping of holes and little tiny screws. Well, the fragments from the tapping operation, the little metal whiskers, were getting inside the jack field. So he decided, well, maybe if I hit it with enough high voltage, I could vaporize the little metal particles. And that's what he did. He built a test set that did that. And suddenly, these jack fields that were being thrown in the dumpster because they didn't pass tests, they were all being cleared up without having to rewire anything. So that's how he got into the high voltage test set business.
I want to take a minute to tell you about my favorite podcast, the Ham Radio Workbench Podcast, with George, KJ6VU, and now joined by Rod, VA3ON, Mike, VA3MW, Mark, N6MTS, and Vince, VE6LK. Every 2 weeks, George and company offer up a status report on the many amateur radio projects on their workbenches and explore projects on their guests' workbenches. This group is project active and prolific, covering many technical areas of amateur radio. So the next time you want a deep dive into ham radio electronic project building, or to learn about technology, tools, test equipment, construction techniques, and the rest, listen to the Ham Radio Workbench podcast, available on every podcast player and channel. Use the link in this week's show notes page to get to the Ham Radio Workbench podcast directly. And now back to my QSO. So how did you end up being his biographer? Is there a museum that's now connected to Wes Schum? Am I hearing that right?
Well, I guess I've got it here.
Yeah, that's possible. Are you offering tours?
Oh, absolutely. If anybody wants to see it, I'll be happy to show it to them. The connection for me was when I was in my senior year at Tulane University. I wanted to get more involved and understand how these broadband output couplers that he and Joe Batchelor had developed for their product line, how they work. And more importantly, I wanted to build my own linear amplifier with it because, Central had teased everyone they were going to build this amplifier called the 2500L. They had the 600L that did 600 watts. They were going to build this big one, right? But it never materialized. I, in fact, do have the prototype test fixtures for it, but that Wes gave me later on. But I went off and decided, I'm going to do this. And so I started researching it, and guess what? There was absolutely nothing available in written form about these broadband couplers. It was like they dropped off the face of the earth as soon as Central Electronics was deactivated. So I got the original patent from the patent office, looked at it, kind of had an idea how it worked, so I tried building them. Well, of course, that met with a lot of failures along the way, or opportunities to learn more. So I started conversing with Wes as I was going through this learning process. And, I'd get to a point where I'd have maybe several different alternatives, and I'd decide to bounce them off of him, and he would say, well, you might consider trying number 3 before 2 and 1. And so he wouldn't give me the answer, but he would let me go down the path till I found my own solutions. And I think he was getting quite amused at this, and but also interested that somebody, excited that somebody was really interested in trying to understand what he and Joe Batchelor conjured up and to make it work. And one day I called him up. There's a friend of mine was working with me. His name is Ron Scalise, K5EF. And said, Wes, I think I got it. And he said, what do you mean? I said, I've got 60 watts drive on this 8877 amplifier, and it's putting out 1750, and nothing's blown up yet. What do you think? He said, bring it up here. I want to see it. So that's what I did.
And did you commercialize that product?
We almost did. At that time, I had my other company. It was called Crescent Radio Electronics. And that was the first company I made after I left Exxon. What we built was one-off things that the oil industry needed. And I also got involved in the paging business.
Really?
Radio page. Yes. We developed, we had a local paging company. This is just when, paging used to be just a domain of the radio common carriers. But the FCC allowed business folks to get into the paging business, but only on a few channels in the VHF band, 152.480.
What was the name of your company?
Crescent Radio.
I wonder if I fixed your pagers. I had a company called Advanced Pager Repair.
Well, we didn't do pagers. We did the transmitters.
So I was fixing in the 80s. I was fixing thousands of pagers.
Oh, well, okay. Well, we probably crossed paths.
That business band, that 152.48 channel, and there's 157.74, that opened the door for a whole bunch of people to get into the paging business.
Paging was a fabulous business. You could get into it on a shoestring, and the equipment was inexpensive. The people liked it. So it worked really well. So we had this local paging company that is called Beepers in New Orleans, and a real flamboyant guy operated it. And he called me up, and he said, Nick, what do you know about digital paging? Said, nothing. I said, great. You think you can, I know you build a lot of stuff for the oil patch and stuff. Do you think you could build us a converter to convert my analog FM paging transmitter to do digital paging? And I said, oh, sure, we can do that. I had absolutely no idea how this digital pager worked, right? But I was in teletype back when I was in high school and college. I'm thinking, it was probably just frequency shift keying or something like that. Sure enough, it turned out that's really what it was. So we developed, my business partner and I, Ron Scalise, and my ham bud, another ham friend. I always had ham radio guys that were in my businesses, and we developed this plug-on device. Eventually started off as a pile of just stuff, all haphazardly wired together. And then we eventually condensed it down to a single circuit board you could plug onto at that time, a General Electric Master 2 FM exciter and make it digital paging. you know. And we had our own signaling format, so you could remotely control it from a paging controller that was some distance away using tone signaling. It got to be, we didn't know it, but there was somebody else that was trying to do the same thing. But we effectively put them out of business. I don't know. I didn't even know that they were there, and we didn't mean to hurt them, but it just happened, And eventually it became if you remember the Zetron paging terminals.
Absolutely. And Glen Eyre later.
They had an option in them for the crescent format, and that was our format and how we control the transmitters. So we had it type accepted, and we sold them all over the place. Paging was a fun business, but that dreaded cellular came in and killed it.
We were fixing thousands of pagers every month, and my father-in-law was my partner, and he would come in and says, "There's no future in the pager repair business." And I would say, "Herb, we're in the electronic repair business." Because as you recall, the old pagers were all through-hole parts, like we're used to. But then you start getting the surface-mounted parts, and we had to buy all the equipment to be able to work on surface-mounted pagers. So I could see as we were going along that it would progress to some other thing, and we were already positioned to do that stuff because we already knew how to work as it's getting smaller and smaller. It was a fascinating time, and I know some people that made millions of dollars becoming paging operators on 152.48.
Yeah, that was the one thing we didn't do. And in retrospect, I told Ronnie, I said, it was fun building the equipment, to do digital paging, but we missed a boat. We should have been an operator.
That's right. Yeah. We all have that retrospect. I want to talk to you about rig restoration, too, while we still have some time. But you said something earlier that caught my attention. Do you think that ham radio operators who get into it the way that you got into it and the way that Wes got into it, that the ability to change direction professionally, to reinvent yourself, do you think that that's something that is just a personality? Or do you think that coming into ham radio as a youngster and then kind of growing through it develops that capability and that character trait that allows someone to reinvent themselves professionally throughout their career?
Well, yeah, as you're a young person, I guess your interest and attention span to certain things changes, right? So, and that's the neat thing about ham radio is that, if you get tired of doing one thing, for example, if you get tired of playing 1010 numbers or chasing DX, there's something else you can do. It's a hobby of different facets. So you can effectively reinvent yourself. You reinvent the hobby by moving into a different direction. And, as a young person, the thing I found that was fascinating about ham radio was it really pushed you to want to learn as much as you could about that one thing that really interested you. And if that string got a little bit short, you can move into another area and do exactly the same thing. So it kind of gave you the tools in order to move into different directions in a professional sense too. But you weren't afraid of making a change. You weren't afraid of trying something different. And I think that's important. Because, no matter what business you're in, there's going to be adversity in it. I mean, there's going to be something that's going to happen that you didn't fully anticipate. So how do you recover from that? How do you change direction? How do you go around the obstacle? And the other thing that Wes taught me was that if you strongly believe in something, you have to go for it with your entire being. You can't hold back. You just have to do it. And in his life, he did it. And he had to reinvent himself. I mean, he was really stuck. When Central deactivated back in 1961, end of 61, he had a wife. His mother-in-law lived with him. He had 4 daughters to deal with. He had his best friend living with him because he had gone through a medical crisis. There was a lot of things hanging on Wes Schum, and and he had a dog. So I mean, he had lots of things hanging on him, and he needed to be the breadwinner, and he had to find a way, and he did. He always did. He was my inspiration. Yeah, he was like a second father to me.
I'm so glad. What you're saying is ringing a bell, because I'm now 66 this week. I've had to reinvent myself numerous times throughout my career. And I always thought it was ham radio. It was the ability to kind of dream up a new solution for something that I attributed to my ham radio life. But I'm glad to hear that somebody else is confirming it or saying it. And maybe that's why I'm such an advocate for ham radio is I meet so many young people who are so focused narrowly on what they can do without realizing if they took an assessment of their skills that they could do many things. Maybe ham radio would be good for you because maybe it would help you prove to yourself that you actually are capable of many things.
Yeah, I believe it gives you the courage to go on, to do different things. Because you gain more confidence in your ability as you progress through the different aspects of the hobby. It really is. I mean, it's a very challenging hobby. It's one you have to earn. It's kind of like driving. You have to pass a test to be a driver, right? You have to pass a test to be a ham radio operator. And you have to continue to learn. Just because you passed the test, that doesn't mean anything. You still have so much more you have to learn. I mean, to be a ham today, I mean, you got to be part mechanical engineer because you got to build your antenna structure. You have to understand a little, about radio theory, so you understand how the thing works. You need to understand FCC rules and regulations. Who reads those? Except a ham operator. So there's so much that you have to. So many different disciplines that are involved in just being a ham radio operator. It's not just grabbing the microphone and talking. There's a whole lot to it, much more to it than that.
Right, just to be compliant with the physics of ham radio means that you have to know about everything it takes from putting that rig on your desk to putting that antenna up on the pole, the house, whatever it is that you're doing. I find that to be true.
It captures your imagination. I mean, even today, all right, with all the internet stuff that the kids have today and how wonderful that is, I would challenge them to find something more exciting than if you were able to put a radio transmitter on the air, transmitter and receiver on 10 meters, operate 5 watts, we didn't enough power to light up any kind of light bulb except the little Christmas lights.
Right.
And communicate with somebody on the other side of the world without any wires or internet or servers or all that other garbage. That's incredible to me. If that doesn't get a kid's curiosity, I don't know what would. Why does that work? How does it work? How is it even remotely possible to work? So there's so many things to learn. Well, hell, I'm going to be 70 years old. I'm still learning it. It doesn't end.
What's the current rig over there?
Where's?
That's not a fair... I mean, I'm looking at you and I can say, oh, well, what's the current rig? You have so much stuff behind you.
Well, actually, I do use this stuff. I get on the air with it quite regularly. Central Electronics 200B and the S-Line. But, no, I've got a real modern rig, actually, one that doesn't have tubes in it that glows.
You have other operating positions.
Yeah, I've got multiple positions, yeah. It's a 2-story building. This is my upstairs. Downstairs is my workshop. But and it's also where my really heavy boat anchors are. I've sent you pictures of some of those.
Because you don't have an elevator.
No.
So you got to schlep it up the stairs.
No, but I couldn't bring one of them up here. It'd be on the ground floor in about 20 minutes. It weighs under 850 pounds. So that's a real boat anchor. No, but I have a Flex 6400M. I have a couple of 1500s. In fact, I'm building up a setup with a 1500 to drive one of the TMC linear amplifiers that I restored. So, new meets old meets new, whatever. Hell, it's all ham radio.
What's your favorite of all of the things that you've restored? What was your favorite restoration?
Well, obviously I like the Central Electronics radios because I restore bunches of them. The most challenging one is a unit that's behind me. You can see the top of it. It's a Collins URC-32. Now, this was the first synthesized Collins radio transceiver that they built back in 1950. It started design work, I think, in 57. They started producing them in 58. They went into ships, and they were still in use until the 1980s. But what's neat about them is it uses some transistor technology, but it also is heavily reliant on these little tiny, some miniature vacuum tubes that are, about the size of this straw, right? And getting that thing to operate, because I got it in pieces, restoring it and making it functional. So I can check in on the Collins single sideband net on Sundays with it. And most of the guys had never even heard of it before, but it's pretty neat to get something like that that's so unusual, operational, and functional again. It's a challenge. Again, another one of those ham radio challenges. You just can't get away from them,
If you do a restoration, is it like a child that you just can't give away? Or do you take them to a ham fest and sell them or swap them for something else?
Well, I do that with the Central Electronics radios because I want more and more people to operate them. So I'll restore them and I'll bring them to, I'm going to bring several of them to the Xenia Ham Fest in a couple of months, to find new loving homes. But there's some radios that I collect that I'll never sell. For example, I've got I was able to buy a Cosmophone 35. Now, Cosmophone, yeah, look that one up, boys.
I'm writing it down here.
Yeah, Cosmophone 35 was termed the bilateral transceiver. And this thing was developed and produced in 1958. It had dual VFOs. It was one box, about the same size as a 75A4. And it was dual VFOs, so you could transmit on either one or the other or whatever. And, it was really a very unique piece of equipment that came out too late. Too late in the sense that Collins had killed it with the KWM1, and then right away they came up with the KWM2, which was much smaller, sleeker, prettier. I mean, there's nothing really attractive about a Cosmophone 35, but it is a unit that maybe only 35 of them survived, and out of them, maybe 12 are operational. So that's kind of fun to do. The other one, this was a horrible one to fix. It's a National NCX 1000. It's a 1,000-watt PEP transceiver. Self-contained. It's got the power supply in it, the whole bit, right? So I got one of those just because it does look neat, right? And I never heard one on the air. Well, I haven't heard any on the air because so few of them actually worked, And when I got to restoring this one, I found, it has lots of circuit boards with these little tiny quarter-watt carbon resistors that had changed value. Normally you see resistor values maybe 25, 30% high, 200, 300% high. I mean, they were like, how is it even possible? So I wound up having to restuff all the circuit boards with all new parts, all new resistors, all new caps. The only thing that didn't really go bad was a little ceramic capacitors. And so I've got it operational finally. It took off and on. It's one of those radios that you can work on for a while and you get so angry with it, you'd have to get away from it for about a month. So it took a year to restore it, but I've got it working. It's downstairs, and I've checked in on nets with it too. They say, what is that? So I like doing the strange stuff. It's fun.
What excites you the most about what's happening in amateur radio now?
I think it's going through, another technological change. What I find is interesting about it is, again, tied to Central Electronics, they were really pushing the phasing method for generating single sideband energy. And with phasing techniques, you can generate upper sideband, lower sideband, upper sideband with carrier, lower sideband with carrier, double sideband with no carrier, all different FM, narrowband, FM, all kinds of different modes, because it's done through trigonometric functions, right? But what are today's software-defined radios? They're nothing more than software equivalents of phasing technology. So what's actually old has become new again. And the way that Wes would have been astounded at how wonderful these new SDR rigs operate, how great the selectivity is. They're like brick wall filters. They don't ring like crystal filters do. If you're trying to operate CW, you have a very, very narrow crystal filter. It becomes tiresome to listen to Morse code through them because they ring so much. You don't have that with these DSP filters. They're fantastic. So I think that he would be really thrilled, and I think anybody would be thrilled with some of the new digital technologies that are coming about, like for example, FT8. I'm not a real FT8 fan because I don't really get a lot of thrill out of seeing two computers communicate with each other. And the only thing I got to do is pay the electric bill for it. But when you think about how efficient it is and the tiny amount of bandwidth that an FT8 signal occupies, which means that you get the illusion that you're actually copying a signal below the noise level. Well, it is. If you look in a 3 kilohertz window, it's buried in the noise. You can't see it. But it has allowed people that live in these HOAs to become hams again. They can actually talk to people again. And of course, you got keyboard to keyboard stuff with teletype and other modes. So I think there's a lot more things to do, even when I was a kid. So yeah, there's a lot to keep a new guy interested in ham radio, or gal for that matter.
What's a GPT 750?
Oh, that's a Technical Material Corporation transmitter. It is a brute. It's about, I guess it's about maybe 4.5 feet tall. It's about 3.5 feet wide. It weighs 850 pounds. It does all the modes. It runs a pair of 400s in the final. It's capable of doing not just single sideband, but independent sideband. So you can actually have different information on the upper and lower sideband of the emitted signal. They were used a lot by the military because you could have a voice channel on, say, the upper sideband, and you could have maybe 4 teletype channels in the lower sideband, using one transmitter. If you do some research on Eisenhower's rail car, it has a communications car that had 2 of these things in it. And Collins built the antenna system that went on the roof of the train car. It's kind of interesting stuff. And the history of radio is so rich. That's why I wrote the book about Wes and single sideband, because most people don't know the history of sideband, how much resistance there was to single sideband back in the 50s and 60s, because so many hams had invested equipment in AM. They didn't appreciate the fact that the ARRL was trying to push sideband so strong and effectively to obsolete amplitude modulation on the HF bands. I mean, it was some serious sideband versus AM wars going on 75 and 20 meters. It was rough.
That's a very interesting idea. So it was an economic war.
Yeah.
You had all of these people who had invested in AM, and now there was this new, it wasn't about the spectrum.
No, it was money. They felt that their investment in time and money all of a sudden went in the tank because the league was pushing single sideband so strong. I even had a column in QST on the air with single sideband. I mean, they were really pushing it. And of course, you had Wes out there, and we went to over 100 different conventions. And conventions back then all weren't like they are today. Everybody's got a ham fest today. Back then, you had regional fests, and not really that many of them, but they were fairly large. So he would go around to each one and sell the medicine, man. As soon as he would get back to Chicago, there'd be piles of orders of new radios in the mailbox. It was amazing. So the AMists felt like they were getting pushed out. They didn't like it.
Your book on Wes Schum is available on Amazon?
Yes, Amazon or Barnes & Nobles, either one.
So I'll put a link to Amazon in the show notes page for anybody that wants to buy your book. They can help the QSO Today podcast and help you sell your book on Wes Schum and his amateur radio history. Before we go, Nick, what advice would you give to new or returning hams to the hobby?
Get on the air, HF air. A lot of the new hams that I've seen at the radio clubs, at least, they hurry up and get a technician license, and the first thing they do is buy a handheld radio, and they get on the repeaters, local repeaters, and that keeps them amused for about a week, and then the interest starts to die off because after you've talked to the same folks a few times, and it has its uses, but that's not the it's not the juice that makes ham radio so sweet. That's on HF. And the time to get on now couldn't be any better. You're on the bottom end of the upstroke of the sunspot cycle. So for the next 5 years, conditions are going to be absolutely fabulous on the bands. These folks can put up very simple antennas. They don't have to buy a commercial antenna. You can build it. You can get all the stuff you need to build an antenna, really from a Home Depot or Lowe's. And you can be on the air in 20 meters or 15 to 10 in a day. And you will just amaze yourself at how this hobby works. HF is the glue. It really is. And the equipment today is so inexpensive based on the capabilities it has. You can go to Hamfest and probably come back with a transceiver that's usable on HF for a couple of $100, or you can spend money for a 7300 that's got everything you need for a beginner to get on the air and with a very respectable signal. And this is the time. I mean, you couldn't find a better time to get into ham radio. The bands are crowded. I mean, I looked at the band scope on my Flex radio before we did this podcast. There's all kinds of signals on 10 meters right now. So, I mean, get after it. That's what I want to do. Get after it. And you do it believe me, you will not get bored. It's a fabulous hobby.
Nick, I know that it's taken us maybe a couple of years to get this conversation together, because I believe I sent you probably an invitation a few years ago, but we did it. We got it all together. I am so grateful that you were able to join me today on QSO Today, and I want to wish you nothing but good health and good luck, and I hope that we have a chance to talk on the air. With that, I want to thank you so much and wish you 73.
Thanks, Eric. I'll turn my antenna towards you. 6 elements at 20 at 120 feet ought to do the job.
I'm looking forward. Thanks so much.
73.
That concludes this episode of QSO Today. I hope that you enjoyed this QSO with Nick. Please be sure to check out the show notes that include links and information about the topics that we discussed. Go to www.qsotoday.com and put in K5EF in the search box at the top of the page. You may notice that some of the episodes are transcribed into written text. If you'd like to sponsor this or any of the episodes into written text, please contact me. Support the QSO Today podcast by first joining the QSO Today email list by pressing on the subscribe buttons on the show notes page. I will not spam you or share your email address with anyone. Become a listener sponsor monthly or annually by clicking on the sponsor buttons on the show notes pages. Your value for value support is recognized on the QSO Today podcast and in the weekly show notes. Use our Amazon link when you shop on Amazon. Clicking on this link before you enter Amazon will allow Amazon to pay us a small commission on what you purchase. This is a very painless way to support the QSO Today podcast. QSO Today is syndicated on every podcast platform, including Spotify and the iTunes Store. Until next time, this is Eric 4Z1UG 73. The QSO Today podcast is a product of KEG Media Inc., who is solely responsible for its content.